Hello everyone, welcome to my channel. So in previous videos, we already talked about how to compute how to describe the probability of two random variables, and then how to compute the mean and covariance of two random variables. So in this video, we want to extend the mean and variance to the more general case. So that means now we not only have two random variables, we can have many of them. So they can be 10, 20, or any positive integer numbers. So to describe this, when we try to compute them, then what we have is we will define a linear function of these random variables. So if you already learned some topics, maybe in algebra or in some differential equation, you can already have what's the meaning for linear function. So here in our topics, the linear functions of random variables means if we have p different random variables denoted by x1, x2 until xp, and we have some constants from c0, c1 until cp, then we can define a new random variables by the linear function of these random variables as c0 plus c1 times x1 plus c2 times x2 until cp times xp. So this is the definition of linear function. So here actually, if you look at this, you know for linear functions it's only by some number constant c0 until cp and this random variable. There is no x squared, x cubed, x to some power. There is no term like this in this function. And also there is no function like sine x, cosine x, log x, exponential of x. They didn't have any equation like this. So that's the definition of linear function of random variables. And then now if we have this new random variable defined by this linear functions as y, if we want to compute the mean and variance of this y, then what we do is actually we can use the properties of our mean and variance. So here, for the mean of the linear function of random variables, we can have the mean of x or expected value of mean of y and expected value of y is equal c0 plus c1 ex1 until cp plus cp times exp. So this actually is a very straightforward extension of our case for the linear relationship or linear property of our mean. So previously we say if we want to compute a mean of ax plus b, then what we have this is equal a times the mean of x plus b. So that means here if we have a random variable times a constant a plus a constant b, then what we do is the answer is just equal a times the original mean plus this constant b, right? So then if we extend this to multiple random variables, the idea is still same. If there is only a constant plus like c0 here, we just plus this c0 to the final answer. And for other term, we just move this constant c1, c2 term out from our expect variable. Okay, so this is our formula to compute the mean or expect value of a linear random variable. And then what about the variance? If we try to find the variance of this linear random variable, then this is definition is the variance of our y is equal the square of c1 times the variance of x1 plus until the cp squared times the variance of xp. And then this is plus the quadratic term. So here this is our covariance of xi and xj for any I and j. Okay, so what this means, actually this is also by an extension of our previous previous example, like ax plus b. So here, what this variance, this will become the square of a times the variance of x, right? So that's why here in our original equation, there is a no C0 term in our equation. Okay, and then the second thing is about what's this quadratic term. So this is because if two random variables don't have any they are not independent with each other. So then except the variance between them, we will also have the quadratic term. So here you can think this is like if we take a plus b and take square of this one. So the answer will be the square of the first term and the square of second term and the quadratic term 2ab. So here this term underlined by the purple color, circled by the purple color, this is similar with the quadratic term in our equation for the algebra. Okay, and then as I said, we know in the previous video we said if x and y are independent with each other, then what we have? We will have the covariance and the correlation of these two random variables will equal 0. So in other words, when here we have x1, x2 until xp are independent with each other, then what we will have? We will have the last term here will become 0. So that is our equation or property here. So if x1, x2 until xp are independent, and we have a definition of our linear function of these random variables by constant c0 until cp is denoted by y, then the variance of our y is only have this p term about the constant square times the variance. And there is no quadratic covariance term here. Okay, so this is the three important equations of the mean and covariance of a group of random variables. And then before the end of this videos, I want to give one important application of this term. So this is about if we know something more about this group of random variables. So for example, if we know x1 until xp follows a specific distribution, then can we have some can we know anything about the distribution of y? So actually the answer is yes. So here if we have xy1 until xp are independent normal random variable, then we can have and if all of them is share the same mean and variance denoted by mu and sigma square, then we can know the linear function of this group of random variables is still a normal random variable. And also we can compute the mean and the variance of this new random variable y. So actually this two term in our notation of normal distribution is just by our previous equation. Okay, so this is one important application of our normal random variable. So please remember here for our question we need have three important requirements. The first thing is x1 until xp are independent with each other. The second is all of them are normal random variables. And the last one is we need to know they share the same mean and same variance. So based on these three requirements, then we can know y is still a normal random variables with this mean, complicated mean and complicated variance. Okay, so this is my explanation of the linear functions of random variables. So this is the end of our sections for probabilities. So later I will start to talk about the statistics. So welcome to subscribe my channel, and I hope I will see you in the videos about statistics.